Happy morning, children. Hope you are all doing good. In our today's class, we will learn in chemistry unit 10 types of chemical reaction. Chemical reactions involve breaking of all chemical bonds and formation of new chemical bonds. The chemistry is all about the chemical reactions. We observe so many types of chemical reactions in our day to day life. The action is also one of the chemical reactions. The plants grows and while we are walking, running, the energy we observe, it's a type of chemical reaction. So, in this video, we are going to discuss about the types of chemical reactions. So, let's move on to this video session. Now, we are going to see the chemical reaction. Do you know what is chemical reactions? Chemical reaction which involves breaking of old chemical bonds and forming the new chemical reactions. This can happen suddenly or some external force or getting into it. That is called as the chemical reactions. We need energy to play, walk, run, or to perform various physical activities. So, first we have to understand the digestion process. While we are intaking the food and the digestion process takes place, that is also called the chemical reaction. Next, the car is moving from one place to another place using the fuel. It is a type of chemical reactions. The plants gets grow by absorbing nutrients from the earth and get their food by photosynthesis. This process is also called as the chemical reactions. Chemical reactions are everywhere. This chemical reactions takes place inside our body or outside our body. So many chemical reactions takes place. For example, burning of petrol, the hydrocarbons present in it are converted into carbon dioxide and water. I gave you two example. One is hair dye, another one is the auto fuel. Next, we are going to see what happens during a chemical reaction takes place. In a chemical reaction, the atoms of the reacting molecules or elements are rearranged to form a new molecules. Second one, old chemical bonds between atoms are broken and to form a new chemical bonds are formed. Next one, bond breaking. It will absorb energy whereas formation releases energy. While chemical reaction takes place, how it is represented by chemical equation. Okay, for that, first the left hand side portion is reactant. The left hand side portion is the reactant and the right hand side portion is called as the products. So the reactant is the stimulate and the product is the response. So chemical reactions are represented by chemical equation. Chemical equations are balanced to show the same number of atoms of each element on each side, either side. Next, the law of conservation of mass says that atoms neither be created nor be destroyed in a chemical reaction. That is why to balance the chemical equations, So hereafter you are not supposed to say left hand side and right hand side. You should say the reactant is always equal to the products. Okay. So next, what is meant by reactant and what is meant by product? First one, what is meant by reactant? Reactants are the starting substances. Reactants are the starting substances that are exist before the chemical change, that is a reaction takes place. This is the reactants. Next, what is meant by products? Products are the new substance that are formed after the completion of the reaction. Combustion of methane. Methane reacts with oxygen to form carbon dioxide and water. So in this reaction does not give chemical composition of the reactants and products. It is only represented by the chemical equation, isn't it? The components or the elements which undergo reactants, which is shown in the left hand side of the arrow, and the product as shown in the right hand side of the arrow. So this arrow mark indicates the direction of the reactions. That is the equation CH4 plus O2, which gives CO2 plus 2H2O. This is the equation for combustion of a methane. In a chemical equation, the number of atoms of the reactants and that of the products must be equal. Okay, so how many atoms should be used in a reactant is equal to the products. Okay, so further balanced equation is represented by the chemical reaction, which describes the chemical composition, the physical state of the substances and the conditions which undergo the reactions takes place. Let me see the symbols of the reactants. First, we have 6 steps. These chemical reactions will have some rules and principles to write the chemical equations. Okay. First, you see this plus sign. This plus sign indicates if you are adding two components. This plus that time we can use the symbol, this plus symbol. Okay, so this indicates the so this plus sign separates more than one reactant or the product. Next, second one, you can see the right arrow mark, which indicates the direction of a reaction. This right arrow mark indicates the direction of a reaction. Next, third one, this symbol S, which indicates the solid state. Next, L, which indicates the liquid state, and the symbol G, which indicates the gaseous state. Next, you can see this downward arrow mark. This downward arrow mark, which indicates the substance is precipitated. The substance is precipitated. This downward arrow mark represents the product or the reactant, anything. It's became as a precipitate. It becomes as a precipitate. Okay, so next, the same arrow mark, if it shows upward, means same arrow mark, if it shows upward arrow mark means what? It evolved as a gas. If it is in the downward arrow mark means it is a precipitated. If it is in the upward arrow mark means it evolved as a gas. Okay, so this is one of the easy step for to write the chemical equation. So what is chemical reaction? What is chemical equation? How we have to write the chemical equation, and what is meant by product and what is meant by reactant, and the symbols we have learnt, isn't it? Now we are going to see the types of chemical reactions. Here there are so many types of chemical reactions are there. How it is considered as a type of chemical reaction? It is based on the manner where the atoms of the reactants are rearranged. Atoms of the reactants are rearranged. So that's why the chemical reactions are classified like this. In this type of chemical reactions, we have 5 types of chemical reactions are there. First one is the combination or the synthesis reaction. The second one is the decomposition reaction. The third one is the displacement reaction. The fourth one is the double displacement or decomposition reaction, and the fifth one is the oxidation, reduction, and the redox reaction. Next, combination reaction. What is combination reaction? It is a reaction in which two or more reactants combine to form a single compound. It is otherwise called as synthesis reaction or composition reaction or formation reaction. Okay, you can able to see the picture. The reactant A combines with B, which gives the product AB. So the left hand side you will have two or more reactants, that is A plus B or A plus B plus C, whatever it may be, but you will get only one product on the right hand side. Combination reaction. What is combination reaction? It is a reaction in which two or more reactants combine to form a single compound. It is otherwise called as synthesis reaction or composition reaction or formation reaction. Okay, you can able to see the picture. The reactant A combines with B, which gives the product AB. Okay, so the left hand side you will have two or more reactants. Okay, but you will get only one product on the right hand side. Okay, so this is the schematic representation of combination reaction. Consider another definition: a reaction in which a single product is formed. Reaction in which a single product is formed from two or more reactants is known as combination reaction. Depending on the chemical nature of the reactants, there are 3 classes of combination reactions are given. First one, element plus element, which gives compound. Second one, compound plus element which gives compound, new compound. Third one, compound plus compound which gives compound. See the first type of combination reactions, element plus element which gives the compound. In this combination reaction, two elements react with one another to form a new compound, whether it is a metal and a non-metal or two non-metals. Okay, so I gave you the example. First, sodium, a silvery white combines with chlorine gas, a pale yellow green gas to form a sodium chloride. You can see this picture equation, 2Na plus Cl2, which gives 2NaCl. Next type of combination reaction is compound plus element which gives a new compound. In this reaction, a compound reacts with the element to form a new compound. For example, phosphorus trichloride reacts with chlorine gas and forms a phosphorus pentachloride. You can see the equation, PCl3. Combination reaction. What is combination reaction? It is a reaction in which two or more reactants combine to form a single compound. It is otherwise called as synthesis reaction or composition reaction or formation reaction. Okay, you can able to see the picture. The reactant A combines with B, which gives the product AB. Okay, so the left hand side you will have two or more reactants. Okay, but you will get only one product on the right hand side. Okay, so this is the schematic representation of combination reaction. Consider another definition, a reaction in which a single product is formed. Reaction in which a single product is formed from two or more reactants is known as combination reaction. Depending on the chemical nature of the reactants, there are three classes of combination reactions are given. First one, element plus element which gives compound. Second one, compound plus element which gives compound, new compound. Third one, compound plus compound which gives compound. See the first type of combination reactions, element plus element which gives the compound. In this combination reaction, two elements react with one another to form a new compound, whether it is a metal and a non-metal or two non-metals. Okay, so I gave you the example. First, sodium, a silvery white combines with chlorine gas, a pale yellow green gas to form a sodium chloride. You can see this picture equation, 2Na plus Cl2, which gives 2NaCl. Next type of combination reaction is compound plus element which gives a new compound. In this reaction, a compound reacts with the element to form a new compound. For example, phosphorus trichloride reacts with chlorine gas and forms a phosphorus pentachloride. Can see the now see the example. PCl3 plus Cl2 which gives PCl5, that is phosphorus trichloride reacts with chlorine gas which forms the phosphorus pentachloride. You can see the one more example, 2SO2 plus O2 which gives SO3. So next, the last type of combination reaction is compound plus compound which gives compound. In this reaction between two compounds to form a new compound. Reaction between two compounds to form a new compound, isn't it? So first we'll see the example. First one, it is given SiO2 plus CaO which gives CaSiO3. So silicon dioxide reacts with calcium oxide CaO which gives calcium silicate CaSiO3. Next, MgO plus H2O which gives MgOH twice. So most of this combination reactions are exothermic in nature because they involve the formation of new bonds which releases a huge amount of energy in the form of heat. So that's why it is a exothermic reaction. Next we'll see the second type of chemical reactions are decomposition reaction. In this decomposition reaction, a single compound splits into two or more simpler substances under suitable condition. So in this decomposition reaction, it is the opposite of the combination reaction. In that combination reaction, what is the definition we studied already? The reaction in which two or more reactants combined. So combination reaction that will combine, but in this decomposition reaction is the opposite to that of combination reaction. So here in this equation we have to split. A single compound is splits into two or more compounds. Okay. So next, in a decomposition reaction, a single compound splits into two or more simpler substances under the suitable conditions. Next, this breaking of bonds is the major phenomena in a decomposition reaction. Hence, it requires some energy to break the bonds. It requires energy to break the bonds. We can see the schematic equation. AB which gives A plus B. That is a single compound. It's split into two or more simpler substances. Okay. Next, depending on the nature of the energy used in the decomposition reaction, there are three main classes of decomposition reactions are there. The first one is the thermal decomposition reaction. The second one is the electrolytic decomposition reaction, and the third one is the photo decomposition reaction. Thermal decomposition reactions. The reactant is decomposed by applying heat. It is otherwise called thermolysis. In this type of reaction, the reactant is decomposed by applying heat. For example, on heating, mercury 2 oxide is decomposed into mercury metal and oxygen gas. As the molecule is dissociated by the absorption of heat, so that is why it is otherwise called as a thermolysis. Okay, so in thermal decomposition reaction, the heat is supplied to break the bonds. Heat is supplied to break the bonds. Such reactions in which heat is observed are called endothermic reactions. In combination reaction, we saw that is exothermic reaction, but here in this thermal decomposition, it is a endothermic reactions. Next one is the electrolytic decomposition reaction. In this reaction, the electrical energy is used to bring about the reaction. For example, decomposition of has this H2O, which gives 2H2 plus O2. Electrical energy is used to bring about this reaction. Another example is given in your book. Decomposition of sodium chloride occurs on passing electric current through its aqueous solution. So, sodium chloride decomposes into metallic sodium and chlorine gas. This process is termed as electrolysis. Okay, 2NaCl on passing electric current, which gives 2Na plus Cl2. Next reaction is the photodecomposition reaction. Here, light is another form of energy. We all know very well, isn't it? So here, this light is another form of energy which facilitates some of the decomposition reaction. For example, is given when silver chloride is exposed to light, it breaks down into silver metal and chlorine gas. As the decomposition is caused by light, this kind of reaction is also called photolysis. 2AgCl, which gives 2Ag plus Cl2. Next is the displacement reaction. So, displacement reaction is a reaction in which a less reactive element in a compound is replaced by a more reactive one. You can see this in a schematic representation. A displaces element B from the compound BC, and hence a single displacement reaction occurs. So A is the element, BC is the compound, which gives AC is the compound plus B is the element. If an iron nail is placed in an aqueous solution of copper 2 sulfate, the iron displaces copper from its aqueous solution, and hence so formed the copper deposits over the iron nail. You can see this. In this tabular column, you can able to see the most reactive element and the least reactive element. First one, potassium, sodium, calcium, magnesium, aluminum, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, gold, platinum. The most reactive element is the potassium and the least reactive element is the platinum. I will tell you how to remember this. Please send lions, cats, monkeys, and zebras into lovely hot countries. Signed General Penguin. So please means potassium, send means sodium, lions means lithium. So like that you can remember this. Next one is the double displacement reaction. While see this picture, you can able to understand what is meant by double displacement reaction. A plus B, AB plus CD gives A will join with D and C will joins with B. So here when two compounds reacts, if their ions are interchanged, then the reaction is called the double displacement reaction. So the ion of one compound is replaced by the ion of the another compound, that is cation can be replaced by other cations. So this reaction is also called as metathesis reaction. Next, we'll see types of double displacement reaction. There are two types of double displacement reactions are there. First one is the precipitation reaction. Second one is the neutralization reaction. These two reactions are very important, children. In the type of double displacement reaction, first reaction is the precipitation reaction. In this precipitation reaction, already we discussed, the downward arrow mark indicates the precipitate. This precipitate will always settle down in the bottom of the test tube. You can see this picture. Okay, when an aqueous solution of two compounds are mixed, they react to form an insoluble compound and a soluble compound. Then it is called a precipitation reaction. So precipitate means insoluble solid that separates from a solution. Okay. When the clear aqueous solution of potassium iodide and lead to nitrate are mixed together, a double displacement reaction takes place between them. Next, potassium and lead displace or replace one another and form a yellow precipitate of lead to iodide. You can see this in this test tube. Next one is the neutralization reaction. What is meant by neutralization reaction? In this reaction is between acid and base. The acid reacts with the base to form a salt and water. It is called as neutralization reaction as both acid and base neutralize each other. Can see this first one, acid plus base, which gives salt plus water. Example is given, sodium replaces hydrogen from hydrochloric acid forming sodium chloride and a neutral soluble salt. HCl plus NaOH, sodium hydroxide, which gives H2O water plus NaCl. Next one, HNO3, acid plus sodium hydroxide acts as a base NaOH, which gives water H2O plus salt NaNO3. Next one is the combustion reaction. in this reaction is one in which the reactant rapidly combines with the oxygen to form one or more oxides and energy, that is heat. Okay, so this reaction of an element or compound with oxygen to form an oxide and produce heat. So hydrocarbons combust with oxygen to produce carbon dioxide and water. So these reactions are majorly used as heat energy sources in many of our day-to-day activities. So heat is evolved. It is an exothermic reaction. As oxygen is added, it is also an oxidation. So combustion may be called as an exothermic oxidation. Next we'll see the example of combustion reaction. CH4 plus 2O2 which gives CO2 plus 2H2O. Next we'll see combustion of LPG gas. We use LPG gas for domestic cooking purposes. We get heat and flame from LPG gas by its combustion reaction of its constituent gases. LPG means liquefied petroleum gas. So LPG is a mixture of hydrocarbon gases. What are hydrocarbon gases? Propane, butane, propylene, etc. All these hydrocarbons burn with oxygen to form carbon dioxide and water. Next, classification based on the direction of the reaction. Changes are occurring every day around us. Is it a permanent or temporary? All are permanent only. For example, liquid water freezes into ice, but then ice melts into liquid water. In other words, freezing is reversed. So it is not a permanent change. Moreover, it is a physical change. The physical changes can be reversed easily. Chemical change can be reversed? Let us see one example. The burning of a wood. The carbon compounds present in the wood are burnt into carbon dioxide gas and water. Can we get back the wood immediately from the carbon dioxide and water? We can't. Why? So it is a permanent change. In most of the cases, we cannot separate, but some chemical reactions can be reversed. Our mobile phone gets energy from its lithium ion battery by chemical reactions. It is called discharging. On recharging the mobile, these chemical reactions are reversed. Mark the 1 marks in your book itself. Write only the question answers in your assignment note. Thank you.